Hey coyotes! I know it's a little different look for me than you're used to. Didn't shave today, doing the casual social distancing look. So we're gonna look at arithmetic recursive formulas versus geometric recursive formulas. So we can compare the two, see them at the same time. We'll have a nice example here on video that you could pause, and hopefully it'll clear up some confusion. All right, so let's start with the arithmetic. One of these problems is going to look like this. It always has these two parts, and it'll have a bracket around it to let you know it's part of the same problem. So this right here, this is the recursive formula. This just tells you what the first term is in the sequence. And they want you to find the fourth term, a sub 4, or a of 4 if we're using function notation. Basically, all this is telling you to do, and this is going to look really like kind of simple to you. Like, really? That's all they're asking? Why don't they just say that? They're really just saying the first term is 5. We don't know the second term. We don't know the third term. We don't know the fourth term. But if you look right here, we're adding 3 as part of the formula. That means that's the common difference. So basically, you could skip using the recursive formula when you're doing Khan Academy and almost kind of cheat. I hate using that word. It's just being clever. All you're really doing is saying, okay, the first term is 5, then add 3 is 8, add 3 is 11, add 3 is 14. There's your answer. Because that's the first term, second term, third term, fourth term. Done. You'd be done with the problem. But let's actually use the recursive formula. All the recursive formula is saying is if you want any term, take the term right before it on the list, that's n minus 1, and add 3 to it. Right? You want to know what this term is? Take this term, the one right before it. You want to know what a sub 4 is? Take a sub 3 and then add 3 to it, and you get 14. Okay, so the way that looks when we write it all out is going to look like this. And I kind of got to kneel to get down here low. So if I want the fourth term, I'm going to take a 4 minus 1 and add 3. Okay, well, what is 4 minus 1 though? That's 3. So we need to take the third term and add 3. Okay, well, I technically don't know what the third term is. I only know what the first term is. All right, well, how do I get the third term then? Because if I had the third term, I could just add 3 and I'd have my answer. Well, I get the third term by taking that and adding 3. Well, what is 3 minus 1? That gives me the second term. Well, that makes sense. If I want the third term, I take the second term and add 3. Okay, well, I don't know what the second term is. So I need to find it. So how do I get a of 2? Well, I'm going to take the term right before it and add 3. What is the term right before it? The first term. Now I actually have one that I know. The first term is 5 because they told me the first term is 5. Okay, so I can go back now and say, well, a sub 1 is 5, so I can replace that with a 5. That makes 8. Well, now I know a sub 2 is 8. So I can erase 8 and replace, or a sub 2 and replace it with 8. That makes 11. Well, now I know a sub 3 is 11, so I can erase a sub 3 and put an 11 here. And I get 14, so a sub 4 is 14. So you're probably thinking right now, oh, is that all we've been trying to do with these? I know the recursive formula is confusing, and it's really simple. So it'd be much easier to just go, hey, here's the common difference. 5 plus 3 is 8, plus 3 is 11, plus 3 is 14. You get the same answer. Okay, let's go over here to a geometric recursive formula. Same kind of deal. Okay, the first term is 5. Here's the formula to get any other term in the sequence. They want to know, again, what is the fourth term. So it's 5. We don't know the second term. We don't know the third term. We don't know the fourth term. But notice the end of the formula, this is the recursive formula, has multiplication on the end. That's how we know it's going to be a geometric one, because we're multiplying. Over here we were adding, over here we're multiplying. Okay, so we could really, again, cheat, take a shortcut, and just go 5 times 3 is 15, times 3 is 45, times 3 is 135. Let me make sure I did that right. 45 times 3, yeah, 135. So that should be our answer if we do this right. Okay, now let's actually use the recursive formula. If I want to know the fourth term, I have to use the recursive formula a 4 minus 1 times 3. So in other words, 4 minus 1 is 3. I'm going to take the third term and multiply 3 to it. Right? Because that's how we got from the third term to the fourth term, was we multiplied by 3. Well, I technically don't know what the third term is. So if I want the third term, the formula says take the second term and multiply by 3. All right. Well, I don't know what the second term is technically. So if I want the second term, I do the 2 minus 1, which is really just 1, times 3. Now I have something I know. A sub 1 is 5. All right, so I can erase this, make it a 5. That's 15. I now know the second term is 15, so I can replace a sub 2 with 15. That makes 45. Now I know the third term is 45, so I can replace a sub 3 with 45. 45 times 3 is 135. Right, so that's the recursive formula. That's it. There's no magic to it. The thing about it, though, is it's not very good for trying to find like the 100th term. Then you'd have to be doing 100 of these steps. You'd be doing it all night. So that's why they discovered the explicit formula. It's faster, more efficient. Next video, we'll compare the explicit formulas.